Oop, mic was on mute. Hello everyone, and welcome to this stream. So I'm working on the variable length quantity exercise on exercism.io. That started yesterday, taking a look at this exercise, didn't get far, didn't write any code, was still trying to figure out what the heck I was supposed to do. Wanted to take the time to read up a little bit on this, but I didn't have the time to do it. Worked on other stuff. So let's try to figure it out together. So essentially, what I'm understanding here is that we're being given a number and it's a 32-bit integer, right? Where did I see that? 32-bit unsigned integer, which means that it's only positive numbers, right? And we're being given that number in hexadecimal, so base 16, which I have never really used before. I know about it. I kind of understand how it works, right? From 0 to 9 eta f, you've got 16, what would you call that? 16 digits? 16, I don't know. Anyway, but for each position you can have 16 values, let's put it that way. So from 1 to f here, once you hit f, you add a 1 here. So f would be the value 16, and then to go up to 17, you drop down to 1, and then 1, basically, right? So if I do that, let's run Quokka here. If I have 1, 1, that should be 17. There you go. 1, 0 should be 16, and a simple f should be 15. That's right. All right, now that I have established that I have a basic understanding of hexadecimal numbers, let's try to figure out what's going on here. What am I supposed to do? All right, okay, so I'm giving 0 here. And it looks like I need to convert that to basically a 2, I don't know if you call it a 2-bit. What do they call that? They say a 7-bit, no, a 2, 3, 4, 5, 6, 7, 8. A 7-bit byte. So this would be this would be a 32-bit byte of hexadecimal, I'm guessing, because a byte is usually 8 bits. So we have 8 positions. But that doesn't make sense, because a bit is specifically for binary, right? All right, let's look at the, that's probably a Wikipedia, yeah, Wikipedia article. A variable length quantity is a universal code that uses an arbitrary number of binary octets, or 8-bit bytes. A variable to represent arbitrarily large integers. If A is 0, the encoding assumes an octet, an 8-bit byte, where the most significant bit also commonly known as the sign bit, is reserved to indicate whether another VLQ octet follows. Right, they say something about that. Right, to indicate, of course. So if you have to unpack it into a series of 7-bit bytes. Of course, you will have a variable number of bytes depending upon your integer. To indicate which is the last byte of the series, you leave bit 7 clear. That's where I'm kind of confused. B is a 7-bit number. And N is the position of the VLQ octet where B zeros near least significant VLQ octet. Ay, ay, ay. Ah. Okay, examples. Okay, this is where I'm confused. So this would be a 32-bit integer, right? Yes. This is in decimal. Okay, here's the worked out example for the decimal number 137. Represent the value in binary notation. So 137 would be, oh, they don't even put it here, but it would be 10001. How do you represent binary in, could I just do this? Nope. That is definitely reserved for hexadecimal. There must be a way to represent binary in JavaScript. JavaScript binary number. Mm-hmm. So it's B. So 0x is the prefix for hexadecimal, and 0b is the prefix for binary. 0x, 0b. I do this, and that should give me 137. All right, cool. And what if I put 1 here? Does that change anything? No, it's got to be a 0. Okay. All right. So represent the value in binary notation. Easy enough to do. Break it up in groups of 7 bits, starting from the lowest significant bit. This is equivalent to representing the number in base 128. What? In groups of 7 bits. 1, 2, 3, 4, 5, 6, 7. And then 1. Okay, what's the point though of doing that? take the lowest 7 bits, and that gives you the least significant byte. This byte comes last. Take the lowest 7 bits. That gives you the least significant byte. 1, 2, 3, 4. 1, 2, 3. That's 8. I don't get it, man. And why do they split that in two? For all the other groups of 7 bits in the example, this is 0, 0, 0, 0, 0, 0, 1. Set the MSB most significant bit to 1, which gives 1, 0, 0, 0, 0, 0, 0, 1 in our example. Thus 137 becomes where the bits in boldface are something where we added. These added bits denote if there is another byte to follow or not. Thus, by definition, the very last byte of a variable length integer will have 0 as its MSB. But that's not the 7th bit, it's the 8th one. Another way to look at this is to represent the value in base 128 and then set the MSB of all but the last base 128 digit to 1. Base 128. The heck is that? Ay, ay, ay. And what's the point of all this? So, okay, so by doing this, so if we take 127 as an example, let's do 7F. Okay. This is 128. Because we've got 1, 2, 3, 4, 5, 6, 7, 8, right? It says, so if an integer is between 0 to 127, it can be represented as 1 byte, right? So if I do, this is 0 here, we've got a 0 here, that's 128. Yet, if I look at this example here, right, 128. switching that to binary gives me 0x81 and 0, 0. So basically 129. That's interesting. So it's some sort of encoding. All right, so if I look at this, take the lowest 7 bits, and that gives you the least significant byte. And you add a 0. This byte comes last. All right. For all the other groups of 7 bits in the example, this is 00001. Set the MSB to 1, which gives 1 and 0, 0, 0. Thus, this 137 becomes where the bits in boldface are something we added. I think I'm starting to get it. I think I'm starting to get it. So I would need, okay, let's try one without looking at the answer. Let's try this one. 8192. I didn't look at the answer, so 8192 is what we're trying to get to. So the first thing we do is convert that to binary, just straight up binary. And to do that, I think we can do 8192 dot two. No, it doesn't work. Or just string, maybe. String. No, that wouldn't work. 2 number 8192 2 string, and then 2 would give me binary, I believe. Right. So I've got myself a string. With 14 bits in it. So what I would then do is, okay, so let's see, this would be, that's binary. I would take that and I would slice it. Can I slice? Yeah. That's probably not the best way to do this, though. I have to make everything into 7 bits. Well, really 8 bits or 7. Anyways, I have to split this starting from the end. So let's just use a for loop, I think. So let I equals binary dot length -1, and then keep going until I is smaller. No, until I is as long as I is as long as I is bigger or equal, bigger or equal than 0, I think. And then we reduce I by 7 each time, right? If we want to split this into 7 bits. Oh. But this, let's see. Let's see if this would work. I don't think it would. So what do I want to do? I want to split this. That's what I want to do. So let's make an array of 7, let's just call it bytes. Array of bytes for now. Essentially push array of bytes dot push. What do I push? I push my binary. Push my binary code. Dot slice. It'd be so much better if I could just consume it. You know what? Let's just convert that to an array. Don't feel like fooling around with the string. Binary. Dot what? Now what? Yes. Const r equals this binary dot. Now, what are we going to do? We're going to slice or we're going to reduce? We're going to slice maybe? Or reduce could be, so yeah, reduce right. Reduce right. Could be interesting. So let's see how would this work. B, C, boom, boom. Do something with that. I want to end up with an array. So we're actually going to need the index. No, that's not how I'm going to do it. I'm still going to use a for loop. For I equals binary dot length. Keep going. Keep going until binary dot length equals 0. Let's do it that way. And then I minus equals 7. Let's try that then. Shall we? Now if I do slice, that just returns a new, yeah. Because strings are immutable. Splice doesn't exist, right? So I could just do this, okay. Let's do it that way. so then I can do, what do I need to put that somewhere else? Const bytes. So then I do binary, not splice, which actually mutates, right? Oh, no, not binary. R dot splice removes elements from an array. That's, yeah, that's necessary. I believe it returns those removed elements. So array.splice, we start at I -7. Does that make sense? I think so. Start at I -7 and the delete count is 7. And that's going to be pushed to our bytes array. Something like that. Now let's take a look at our bytes. Well, that worked well. Length -1. So what's happening here? We're not even reaching this twin white, so why? If I did it the way I did it before, that's going to be a problem, though. Oh, now what? Oh no, that's not. That's what I wanted to do. Okay, interesting. Obviously, that's not right. Oh, and also, crap, it's true. So it can't be push, it's got to be, because we want to start at the end, so. What is it? It's not shift, it's unshift? What's unshift? Inserts new elements at the start. That's what we want. Okay. It's closer to what we want. But now we're not. How do I do this? Keep going until I is bigger or equals to 6. This should give me an even. No? 1, 2, 3, 4, 5, 6, 7. About to 7. Okay. 2, 3, 4, 5, 6, 7. Then what is left in my R? We've got a 1, 2, 3, 4, 5, 6, 7. We've got 7. So I is now equal to 7. Were I to try to do this here, I would do I minus 7. So I is now 7. And that didn't work. Wait, as long as I is bigger or equal to 7. Right, if I were to make this 6, it just grabbed the 1. That's interesting. What if I were to make this 8? Doesn't change anything. Let's think about this here. So we're starting off at array length, which is 14 minus 1. So we're starting off at index 13. Is index 13 bigger than 7? Yeah, cool. So now we do this. We splice 13 minus 7 would be index 6. So we're starting off at index 6. And we're splitting 7. Oh. Right, 13 minus 7. 6. Index 6 would be the 7th number. I do have 7 here, so I'm fine. 3, 4, 5, 6, 7. Alright, maybe I should just change this so it's easier to keep track of what is actually being... so let's just do string 3, 4, 5, 6, 7, 8, 9, 10. No, I can't do that. 10 would be 0. Actually, let's make it like the index is 0. 10 is A, B, C, D. That's 10, 11, 12, 13, 14. Okay. 0, 1, 2, 3, 4, 5, 6. Cool. And 7, 8, 9, 10. 7, 8. 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Oh, right, because I started it. Cool. Oh, that's interesting. So, okay, that's what I thought. It didn't split. So maybe I do have to start here. Aha! 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D. So that works. Cool. Okay, that's exactly what we wanted. Good. So that part's done. We've got ourselves a this thing broken down in 7 bits. Now, once we've got that, we need to go through my bytes array. Yeah, I go through my bytes array and I map this by let's think about this here. What do I need to do? I basically just need to add a 1 or a 0. So, okay. I don't know what I'm going to call this, but let's call this 8 bits. And this will be 7 bits. Bytes. This will be 8-bit bytes. Oops. Like that. Okay. This for now. Map. And this is a byte. And we are, what are we doing? We're doing, basically we're doing if byte, no, actually I need the index, so I've got access to this and that. So if I is equal, actually it's if I is, yeah, if I is equal to a dot length -1, in other words, if it's the last byte in the array, then we return our byte. Byte here happens to be what? A string array, right? So byte, let's just do it that way. That'll be nice and da-da-da-da with a 0, like that. Otherwise, we return 1 byte. And there we go. Now we've got our 8 bits bytes. Let's take a look. 8 bits bytes. Believe that's right. Now I need to convert that to hexadecimal. So const, or what do they call this here? They call it V VLQ, VLQ, VLQ. It's called VLQ. Const VLQ equals 8-bit bytes dot map. We're taking the byte. We're basically doing byte dot actually I think parse int. No, the byte is an array here, right? It's an array of strings. Oh crap. Ooh, almost made a big boo-boo. Okay. Right. So what are we going to do with this? We're going to first convert. Okay, I'm going to need to do that on more than one line. So the byte's going to be converted to an actual string. Right. And once we're done with that, maybe I can just do parse int. Yes, and the radix is going to be 16. Let's take a look at VLQ. Undefined. Cool, 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 cool. That is what I was hoping for. Not. Okay, that's just because I wasn't returning it like a retard. There we go. Okay. Interesting. That can't be right. What am I supposed to get? Not that, that's for sure. I'm missing a step. 7 bits in the example, set them as bits. So I think I've got that right. Can I confirm that? 1 1. Yeah, I think that's what I got. In terms of 8-bit bytes. Right, 1 1 0 0 0 0 0. So that's correct. Let's just remove this for now. Yeah, so that's correct. What do I need to do then? These added bits denote if there is another byte to follow or not. Thus, by definition, the very last byte of a variable length integer will have 0. Another way. That's weird. Oh, silly moi. Of course, parseInt is not the right thing to use here. Instead, what could I do? So I've got a string that is binary, and I want to switch it to hexadecimal. I could convert it to a number, then convert it to, let's try that. So if I did number with this, and then toString, pass in 16, nope. Nope, 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 nope. What if I did this though? What am I getting? That's correct. Hmm. Oh, crap. No, okay. Okay, 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 okay. Whew. Boy. Okay, so number. So, okay, parse int. Well, actually, it's in base 2. Good. Right. It's in base 2. And then I want this to be in base 16. Aha! C0, 0. I think that's correct. Yay. Okay. So I think we've finally understood. Kind of a complicated process. Now if I look at what we're actually expected to produce. Oh man, they want the 0 and the x and the... Okay, they want it passed in as... to equal... Oh, actually... Not really, right? We don't really need to return it in hexadecimal format. Our tests are checking to see this is just equivalent to equal. I guess it depends. Used to and check two objects have the same value. Let's do a quick test here. See if, for instance, 0x 0 is equal to 0b 0. Yep. Alright, so you can compare value between just regular numbers and whatnot. So I might be able to skip this step altogether. Alright. Let's start implementing our class here. Just going to keep that down here for reference for now. So we need to export a default class. We're going to call it VLQ, and it's got a static encode. Got it. Export default class VLQ. Man, it's got a static encode function that takes in an array Yep, an array of, I'm gonna say type number. Would that be right? I guess so. Integer is a number array, basically. And we're going to be expected to return a number array as well. All right, so we take our integers for, so this one encodes 0. Well, let's just implement the whole thing. I know what I'm doing now. So, wait. I can actually be fed more than one integer. Ugh. That's interesting. All right, let's worry about the one for now. Although they probably won't be done separately once we get to having more than one. Let's see here. Okay. Let's get one thing at a time. So we're actually encode a series of integers, producing a series of bytes. Am I supposed to, let's go read the definition of our problem here again in short. So implement in short, the goal of this encoding is to encode integer values in a way that would save bytes. Only the first 7 bits of each byte is significant, right justified. Sort of like, so if you have a 32-bit value, you have to unpack it into a series of 7-bit bytes. Of course, you will have a variable number of bytes depending upon your integer. To indicate which is the last byte of the series, you leave bit number 7 clear. In all of the, I don't think that's right. In all of the preceding bytes, you set bit number 7. From what I'm reading here, we're setting bit number 8. Right? 1, 2, 3, 4. 1, 2, 3. And then this is the bit that we set. Boom. It's the 8-bit. Unless it's 0 index? Oh, that might be why. No, I don't think so. I don't know. Huh. Gonna have to... But anyways. So if an integer is between 0 and 127, it can be represented as 1 byte, although VLQ can deal with numbers of arbitrary sizes. For this exercise, we will restrict ourselves to only numbers that fit in a 32-bit unsigned integer. Okay. So I think I need to deal with each integer in the series individually. So we're going to make a, let's see, if I did integers, dot map. Should be interesting. Could do a bunch of maps, because that's really what we're doing here. We're mapping one thing to another, and to another, then to another. So first things first, I need to end up with a binary representation of my number. That's the very first thing I need to do. So if I take for instance, my 8192, I could probably do integer to, that's right, to string, boom, I've got it as got it as a binary now. Wonderful. Now I can map this again. Okay, this is where I need to split this. So I don't think a map will work. All right, let's not do that in here. We're gonna do another static. Can I have private, static private? I think so. Static private. Although it's, oh no, I think it's private static, right? That's right. Static private. Let's call it encode 1 integer. How's that? Just give me an integer type number, and I'll return a number. Yeah, I think proceed, that's right. It's private static. Private static. Although, why not? Presumably you could use that somewhere. Okay. So first thing we do, binary. Pass in our integer. Boom, to string 2. So we're going to call this binary string so that we know that we've got a string. Wonder if there's not an easier way to do this. And keep it as an actual, do I need to? Yeah, I want it as a string anyways, okay. Because now I need to do the equivalent of this here, which is to basically slice my binary string so we're going to slice this into bits, right? Seven bit bytes, 7 bit bytes. Thing like that would work. And then once we have that, we can do this. Mm-hmm. And then once we've got our 8-bit bytes, what do we need to do with it? Still a string of string. So we can do this. An array of string, I mean. An array of string. So I need to do that. Where VLQ is actually probably right. We don't want them. We don't want it as a string. And we can just return VLQ. So then in here, I can just do return integers. Oh, I need to flatten all of that stuff though. Okay, so if I did integers dot map, I've got my integer here. I pass it through my encode one integer. I end up with a probably yeah. I want to flatten that. Turn blah 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 dot flat. Can I do flat map actually? No, that wouldn't work because let's see. first of all, I need to bring that in. Lib. Yes. Next. This is supposed to be inside an array. Okay. Then I need to update TypeScript. Like that. 11 problems. Take it easy. There. Yeah. I need to be in my TypeScript and variable length quantity, and then npm install. Just updating TypeScript so that it works with. Oh, it might not though, because I don't know if Node. Yeah, I've got the latest version of Node. Let's try this. Returns a new array with all subarray elements concatenated into it recursively. And calls a defined callback function on each element of an array, then flattens the result into a new array. This is identical to a map followed by flat with depth 1. That's interesting. So this would work, I think, if I did flat map here. Let's give this a shot with, let's run Quokka. So VLQ dot, what did we call this thing in code? If we pass in, what was that number we were trying? 8192. Oh, it needs to be an array. 8192. We're returning 192 and 0, which I believe is correct. We had, where's that? 192. So this would be, this would be 192, wouldn't it? I think so. Yeah. Okay, so I think this works. Interesting. Now let's try to run the test on that thing. See what happens. All right. All right. What seems to be the problem? Code is declared here. Oh, decode? Did I screw this up? Where's my source? Okay, here. Encode. Oh, I'm expected to decode as well. Ugh, look at that. Well, that should be relatively trivial, I would think. Static. Okay, let's make that here. Static decode What are we decoding? We're passing in, again, just an array of numbers. So it's essentially the same kind of signature, I guess. Number array returns a number like that, like this. And for now, just so that it doesn't complain, let's return this. Oh, so actually, how about that? Just return integers. Okay. Now it should compile and run our first test case. It was just complaining because it failed. No, 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 no. It's unacceptable. What seems to be the problem? All right. I'm expecting an array with just a 0. Instead, I receive an empty array. Ah, that's a pain. That is a pain. Let's try. Let's see what happens with this then. VLQ.encode. What are we passing in here? We're passing in just an array with 0. That's interesting. I wonder where this goes wrong. Start on current file. Aha. We are not pushing anything to our 7-bit bytes thingamajigger. Right, for let I equal bits.length is 1. If I is bigger or equal to 7, which it isn't, crap. So what if I just did, okay, hold on. What if I just did 1? Oh man, everything under a certain number is not going to work, it would seem. Yeah. '64 works, 63 doesn't. Yeah. I know why. So that's a problem. This here is flawed. It is flawed because damn, how am I going to do this? So I need this to work even when there's less. All right, let's do a quick check here. This is a solved thing, right? So slice array into slice array evenly from the right. Yeah. And chunks of the same size easily in JavaScript. Problem is, I'm trying to do it from the other end. Lumi! Hey, Lumi. How you doing? Right now I'm just trying to chunk an array, basically by I'm doing good. I'm doing good. Thanks. I'm trying to chunk an array from the right into chunks of even size, of the same size. Push the slice. Yeah, I guess it doesn't matter performance in this case. That's not a bad idea. That is not a bad idea at all. Just reverse it and wait. If I so reverse it and then reverse it again, is that no, hold on. Reverse it. So right now I had that. But yeah, just realized it didn't work. Whenever it works for over 7, if your array has more than 7 elements, it's just when I get to get an array that has less than that, then it goes to. I guess what I'm having a hard time dealing with is like the remainder. So I start at the end, right? Index it starts being, the last index in the array. And I'm using unshift. I'm using splice, sorry. Yeah, I'm actually, it's a VLQ thing. So I need to, the way I'm doing it is I'm being passed an integer. I convert it to binary. I slice up the binary in 7-bit bytes. Then I iterate through each byte and add a 1 at the front if it's not the last byte in the series. And I add 0 if it is. Then I take all of that stuff and I basically just parse it back to integers. And it all works. My algorithm is all fine. It's just I kind of screwed up this little part here, the splitting into 7-bit bytes. It works for any number that's bigger than 64, right? Because like 1,300 whatever, who cares, right? This works. This is correct. But 63, boom. Because it doesn't, because it's less than 7 bits. That's why. So let's see, what did we have here? Using a for loop, slice and set function in prototype of array. No, I don't want to do that. Using array map in the prototype of array. Do not want to do that. Using a while loop and slice. Chunk size, y results, while my array dot length, results dot push, my array dot splice. This is similar to what I was trying to do, except that I need to do it from the end. And if I reverse it, I don't think that's gonna, oh, I could, if I reverse it, I would have to re-reverse each byte afterwards though. Would that work? Just completely reverse it, and I start. Actually, I just thought of something. What if I tried a much bigger number? Just want to make sure I have the right output. I should be getting this here. Yeah, so that's right. So my algorithm works. It's just that I need to fix the splitting. So let's think about this. I need some way to iterate from the end all the way to the front. I'm probably just trying to force this into a regular for loop when this isn't the right kind of loop to use here. Because this all works up until you get to you know, smaller than 7. So let's take, for instance, say 7. And that's the problem, I guess. Okay, so if I do, say I do simply 8, then my binary string would be right 1000. Convert it to bits. Then of course when I get to bits.length, it's like, oh, it's smaller, so it just doesn't even deal with it. And I think that's where the problem is. If I do 64, now this happens to be 1, 2, 3, 4, 5, 6, 7. That's right. We're good. Now if I did 63, 128 is 8. 6, 7, 8, that's right. So maybe I should pad it. That would be a simple way to fix my problem. Oh yeah. Why didn't I think about that? Let's just freaking pad it. Alright, let's do that. Just add a bunch of zeros in front. That's all. Oh, hold on. No, that would screw things up. When I get to 8, let's see. Oh, maybe not, actually. How am I dealing with this? 8-bit bytes. And if it's 0, I'm still going to be doing... Yeah, that'll screw things up. Darn. Let's try it, though, just for fun. Where could I do that? I could do it here. So to string, I could do simply like this. 5, 6. There we go. I'm certain now that I have at least this much, you know. If I encode... Hey, Nel2. Doing good, you? So 127 I think they had in here, yeah. And there's our proof that I screwed it up. Doesn't work. Right, it should just be 127. Now I've got a 128, yeah. So I can't do padding. That's not a good solution, on top of being stupid. Yeah, that's a good idea. I should make that a command exclamation mark problem. I'm working on the variable length quantity exercise on exorcism.io, where you need to convert a integer into a VLQ, kind of a weird thing that I wasn't familiar with. But you're basically taking an integer and you're converting it into variable length quantity. I guess the output doesn't matter. It can even be, you can feed back an integer, but anyways, you have to break it down. You basically have to break it down into 7-bit bytes. Add a 0 or a 1 in front of it, of each byte, depending on whether or not it's the last byte in the series or not. And then that's pretty much it, really. Right now I've got a stupid problem though. My algorithm works. It's just I'm trying to figure out a way to split my oh, well, let me show you here. 127. Let's do my 63 example. See how it'll output just an empty array for anything that's below 63. If I go to 32, if I go 1 or 0, but if I go 64, then there you go. It'll output something, 64 or even 128. 128 should not be outputting 0, right? That's weird. Did I change something here? Or maybe it should. That's interesting. 128. No, I'm missing the front part of it. Interesting. But if I do 129, oh yeah, I screwed something up. What did I change here? Yeah, I had to do that too. I had to look at the Wikipedia article as well because this was all new to me. Well, to start with, I had never really used hexadecimal. Knew what it was, but never really used it before. Um, so if I have 64, this will work. If I have 129, I've got like 1,000 something. Okay, so I do have a problem here. It's not quite right. Yeah, there's definitely a problem with the way I'm splitting my array here. I need to find a better way to do this. What I need to do is let me show you. I've got here we go. So I've got an integer. I'm converting it to binary, a binary string representation. I am converting that just to an array, just because there's easier to manipulate. So an array of bits, really. But now I want to split that array of bits into 7-bit chunks, starting at the end. Right? So, for instance, if I had a bits array of 9 bits, I would need my 7-bit bytes array to have the first element be a 2-bit array, and then the next element be a 7-bit array. And I'm having a hard time figuring out how to do that. I was trying to use just a for loop, but I don't think that's the right way to do it. I could use a while maybe. Could try that. Wait, you did it right? No, I don't think so. I do not think so. Here's the proof. When I have like a number that's less than 7 bits, I mean, if I have a bits array that is less than 7 bits long, it just won't do anything with it. See, like 12. 12 is just 1100 in binary. And then as you can see, like when it gets to the for loop, well, condition's not met, so it just skips it altogether, and 7-bit bytes remains empty. So I think I might try using a while loop maybe. What I would do is take number remainder operator 128 and then convert it to binary. What would that do? That's interesting. So you check if Ooh, now we're getting into bitwise operations and stuff. Ooh. And loop till number. Can you throw that in the gist maybe for me? So I get a better sense of what you're trying to achieve there, what we'd be doing. Yeah, no problem. Meanwhile, I'm just going to work on a very stupid way of doing this. So I'll keep going as long as we've got stuff in there. Would be one way to do it. And then we just do, hold on. How was I doing this? So while bits dot length, keep going, and I need to push, or actually unshift, bits dot splice. I could probably do bits dot length minus 7. Would that work? Would that work? What am I doing essentially here? I am got bits dot length. Cool. Oh, I see where the problem is, because I think splice, when you have a minus, okay, man. If you pass in start, okay, if you pass in the index at which to start changing the array, if greater than the length of the array, start will be set to the length of the array. If negative, it will begin at that many elements from the end of the array. Aha. Mm-hmm. Okay. So I can just simply do -7. Aha. Aha. I think I might have just fixed it. Yeah, I think I just fixed it. and it was much, actually, this is much simpler than, I don't know what the heck I was doing there. Oh boy. All right, let's take a look at this. Uh, All right. Raw paste the data, JavaScript, okay, code in. Let chunks while n is bigger than 0. Chunks that unshift n 8. Okay, what's, oh, okay. So you wouldn't even so you'd be skipping while, okay, so if we're doing this, we'd be skipping the converting it to a binary string, if what I understand. You're just straight up taking my integer. Okay. All right, let's think about this. chunks dot unshift. So while n is bigger than 0. So we're taking last 7 bits. All right, let's hold on a second. I'm intrigued. So this here, you're taking, so let's say my number was 129 for the sake of actually, let me just, I'll paste that in my file and we'll be able to play with it right here. All right. Code 129, let's say. So so that the linter doesn't bug us. Here we go, type number. Okay. There. All right. So first thing we're doing is we're getting the remainder of 128. So we've got 129, the remainder is 1. So boom, shove that one in here. Then we're taking n, and we're making n equal to n right shift 7. So we're shifting, how does that work again? That would return, I really don't use that stuff often at all. Oops. So let's just take a number like 7, for instance. Get 0. Or in our case, it's 1, right? No, it's not. It's 129. We're not. Right. When we're right shifting, what are we doing essentially? We are, isn't it like a division? Let's see. Sign propagating right shift. This operator shifts the first operand the specified number of bits to the right. Excess bits shifted off to the right are discarded. Copies of the leftmost bit are shifted in from the left. Since the new leftmost bit has the same value as the blah 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 Chinese. All right. 9. Here's an example. So that might be. So this is a 9, right? And base 2. All right, that's 1. This would be. Yeah, okay. And if we're shifting 2, we're basically just, okay, and this becomes a 2. I get you. You're just moving everything right. So if you're moving everything right to by 7 bits, if you're moving everything right by 7 bits, you're changing the, oh, I get it. Okay, and then we loop back again as long as we're bigger than 0. I like it. It's a little harder to understand when you're not used to it. But essentially, so if I take Maybe just a bigger example. Let's do 256. No, let's go bigger. 512 maybe. Nah. 1024. Nah. 9,000 something. Okay, not that big. Yeah, oh, it is much more, no doubt, much more efficient. Yeah, I just want to understand it fully if I'm going to use it. Yeah, that's right. Makes sense, right? So, let's think about this. We've got 9065, so this would be in, just so that I can see it. Just for fun. Right. What's the smallest one I can use that will have? Interesting. Right. Right. That's right. Okay. Okay, that's cool. So let's do 129. That's what I was doing. Hmm. All right, man. Thanks for your help. So that's interesting. All right, so if I was to do this, first I do 248. Actually, I can probably just throw that in here. No, it doesn't work. Oh, yeah, it does. Interesting. So, first thing we're doing is 248 modulo 128. Right. And that gives us 120. Cool. So we stick 120 in there. And then we shift n 7 bits to the right. So 248, shift 7 bits to the right, we end up with 1, because if we do, we've got 1, 2, 3, 4, 5, 6, 7, 8, so we get 0, 2, 3, 4, 5, 6, 7, and boom, the only thing that's left is a 1. I like it. I like it. I like it a lot. I like it a lot. So by doing this, we're basically just grabbing and then if it was a bigger one, we just, yeah. Very cool. Very cool. I think I've got a good grasp on what we're doing here. And it makes the code much shorter and more performant. Albeit not as easy to, but I mean, it is an exercise about dealing with bits. So I have a hard time seeing that any mentor would give me a difficult time for using bitwise operators. So I will, I think. And does this replace, this replaces my entire function, doesn't it? Although, actually this will replace encode one integer. Let's not get rid of everything yet. Try that. Oh. Crap. Got the same problem here. It won't encode 0. It'll do 1 though. But 0 doesn't work. Well, I basically just have to... What if I did this bigger or equal? What would happen now? Well, if it tried to do that, there's no remainder, right? Because if we... let's forget about that. Right, if we tried to do 0, 128, what's the result of that? It's 0. Okay. The thing is, we never get out of the loop if we did that. All right. So what would be a good way to deal with this? I could simply do I could just check if integer is equal to 0. How about that? Just return an NT error. Not an NT, but return this. Oops. Like that. That would work. All right. So I think I can get rid of that for now. I can also get rid of this. This is fine. That. Let's try our test, which now should work. Cool. Next one. Cool. So let's open this up here. Oops. Doesn't work for everything now, does it? Let's dial that back. Interesting. So it's when we get to double bytes that it's no longer working. We are giving 10 when it should be 129 0. Let's take a look at this then. LQ dot encode. What are we passing in? Passing in this. Oops. And that is the equivalent of 128, right. $128 should be 810, right. All right, and of course this isn't working because we're not, this is just one part of the equation. This will just split my, this will just split my, okay, I think I know what's going on. But I'm out of time for today, so I will have to keep working on this tomorrow. But I think basically what's going on is that we're doing our splitting in 7 bits here, but I need to add a 1 or 0 in front of each of these chunks, basically this part here. So I'm going to have to look into this. But I think that's the only thing that's missing. All right. To be continued. See you guys.